Welcome to my presentation on global trends in surgical research. Addressing some background information, research as a whole requires high quality and a maintained level of integrity in order to provide the best evidence for the patients, allowing them to receive the highest level of care. The field of surgery in particular demands an increased need for quality in its evidence base due to the invasive nature and large risk of harm involved. Additionally, surgical research is disadvantaged due to the difficulty in performing randomized control trials as a result of obstacles in design with regards to randomization, blinding, and ethical restrictions. As a result, the purpose of this research is to gain insight on what the research pool looks like for the highest quality of evidence in surgery, examining the volume of surgical RCTs and how these trends are changing over time. With this, we will obtain an understanding on characteristics of the studies, changes over time, and thus we will have a valuable perspective for the integrity of the conducted research. Finally, evaluating this research on a global scale is crucial to determining where discrepancies and inequalities lie within this evidence base. In an attempt to capture all of the studies registered globally that involved surgery and a randomization of participants, the search was created to be exhaustive and comprehensive. Since clinicaltrials.gov is a well-known database for registering trials across the globe, including 219 countries, both federally and privately funded, it was used for this research. The platform was created in 1997, so therefore this particular start date was chosen. After the search, restrictions were placed on interventional studies and date ranges, and then all the studies were pulled and screened for inclusion. The inclusion criteria only required randomized allocation in that a surgical procedure has taken place, which was defined as an incision made using a cutting tool while undergoing either local or general anesthesia. Most of the data was extracted from clinical trial registries themselves. However, not all the registries were thorough enough to include all this information, so we searched through additional data such as published protocols and published studies if available. The only value not obtained from clinical trials was the HDI level of the countries, which was retrieved from the United Nations 2019 report. Based on exhaustive searches on clinicaltrials.gov since 1997, there have been 376,522 registered trials up until the present day. Out of these, about 78% were interventional, 52% were randomized control trials, and about 9.5% were surgical RCTs. For the purpose of this research, we only looked at trials registered up until the end of 2017 to allow time for study completion so that we can assess this value as well. This modified search allowed us to identify all of the possible surgical RCTs, extracting just under 25,000, and then going through all of them following the inclusion criteria, 13,900 were kept. This is suggesting that the numbers seen below didn't go through screening for inclusion and are overinflated, as only 56% of the extracted surgical RCTs actually fit the inclusion criteria. Also keep in mind that these are only the registered trials and not the totality of the published work in this field, as not all of them will end up making the publication. As expected, the number of studies registered each year is drastically increasing as the years progress. However, the completion status of these studies is not increasing proportionally and rather flattening out around year 2014. The figure below shows the percentage of completed studies over the year, where the figure above in the right shows absolute total studies registered with how many of them were completed, and below that one shows the cumulative amount of registered studies with the cumulative completion amount as well. As seen, the gap towards the more recent years of registered and completed studies is increasing and shows a plateau in the above one. With the average completion rate of 2.4 years, it was originally expected that ending the date range at about the end of 2017 would be sufficient for completion. However, as per these figures, either it was not enough time for completion or the completion rate is truly dropping to this drastic extent. But this cannot be assessed without further data from the coming years to see if this trend persists. Nevertheless, completion rate is still consistently decreasing. If this is the case, it provides negative implications for research integrity, as valuable resources and time are spent for these trials that never end up reaching completion. More telling for research integrity would be to look at results of the unpublished trials and see why they're not being completed. However, without this access, this claim cannot be made. The average enrollment size across all the studies was 262 participants. Again, a reduction was seen where the average in 1997 was 305, but the average in 2017 was 181. This trend of reduction can be seen within the graph by the size of the bubbles as they are getting smaller with time. When comparing enrollment size of the completed versus the not completed studies, a difference was not really seen as they are approximately the same. Although it could be seen as concerning that sample sizes are decreasing, providing less confidence in the data, there are many possible justifications. For one, better understanding of sample sizes and lack of necessity for huge trials that would provide similar confidence of results compared to one of smaller and adequate sample size is likely to be seen over time. But more so, large surgical trials assessing general questions have likely been undergone earlier in the years, and it would be unethical to reproduce these trials as we have a pretty good understanding of the results. Accordingly, esoteric demands and subdomains of these general matters are more likely the question at hand for the more recent years, which don't affect the general population, rather a smaller, more niche subgroup. Moving on to the countries and human development indices, an overwhelming 82% of the studies were planned to be conducted in very high-income countries, represented by the darker blue on the map. To compare this to the low-income countries, represented by the darker red on the map, they encompass only 0.31% of the studies, creating a difference of 81.73% between the two. Looking at the visual that represents absolute number of studies per year, it is clear that the high and the very high income countries are producing most of the studies, and that this level of production is growing each year. In contrast, the low and medium income countries are for the most part remaining stable in their growth, which is generally near zero. It is also evident that regions of higher income are producing most of the studies, and they're coming from majorly North America and Europe, but also from scattered parts of Asia. This is a huge issue in relation to applicability of the research and generalizability when it comes to reviewing the evidence for use of surgical application in these regions. It is important to produce research proportionally to where most of the world's population lies and would benefit from, and this is not necessarily the case here. Looking at the types of surgical categories is also a good indicator to the applicability and generalizability of the evidence base across the globe. Seen by the light blue bar in the bar graph, the very high-income countries are consuming most of the space in the bars, with the majority of studies within orthopedics, cardiothoracics, gastroenterology, and obstetrics and gynecological surgeries. Seen in the pie chart, the very high-income countries also have a large variation of surgical categories, encompassing each category to a certain degree, with the largest sections in orthopedics, cardiothoracics, and gastroenterology as well. High-income countries have a decent variation as well, similar distribution to the very high, but also taking a large portion of the obstetrics and gyno category. When looking across the years, the medium category doesn't even appear until 2001, and the low-income category doesn't appear until 2007. That's 11 years into the data. Both appear with only one category of obstetrics and gynecology. Although this is clearly an issue for generalizability, it is congruent with the events occurring in these regions, as medium and low income countries tend not to have access to cardiothoracic equipment, for example, which is largely seen in the higher income countries. However, they are generally known to perform lots of obstetric and ophthalmic surgeries due to the incidence of these types of issues in their regions. Implications of this research are fairly consistent across the categories. While it is positive that there is a relatively large volume of registered RCTs, there is also a significant proportion of them remaining unpublished. As mentioned previously, this holds large implications for the research integrity involved, as a large portion of the evidence base is not published, and without further analysis on the unpublished work, it is difficult to declare why this is. Additionally, the overwhelming proportion of studies is within the high and very high income countries, raising concern for the generalizability and applicability of the evidence, urging a more balanced proportion of these studies and surgical types produced in relation to where the world's population lies. Thank you for listening. I encourage you to check out the interactive dashboard poster for more details on specific graphs and statistical measures over the years.